Hello, everyone. Welcome to Kneron's 2021 Semiconductor Product Launch. Thank you for joining us here on the edge of next-generation AI possibilities. I'm Charlene from Kneron CEO office, and on this occasion, I will be moderating our event, which includes a keynote from Albert, our CEO, detailing Kneron's latest technical and, of course, product advancements, alongside 3 panel talks on the future of automotives, AI and open platforms, as well as the AIoT market at large. Special thanks to the Global Semiconductor Alliance, Winbond, YouTube, NASDAQ, Race Capital, Flucas Ventures, and Kleiner Perkins for joining today with insights to share. Now, without further ado, I welcome Albert to start with a big reveal.
Well, thank you, Charlene, and thanks to everyone for joining the team for our next generation hardware product launch. We are honored to share with you Kneron's latest technology advance. As a leading full-stack AGI company, we offer hardware, software, toolchain, integrated module solution, and now also an AGI open platform. Today, however, we are specifically delighted to be launching our next generation hardware solution, the KO530. And we are excited because more often than not, hardware constraints really are the bottleneck of what AI can do. Before I jump into the review, however, I would like to walk you through a bit of Kneron's history and recent updates. Established in 2015, we are a San Diego-based company. Today, we are 210 strong, 75% of our talents are in R&D, and we are 100 million USD dollars in funding. The company was founded by Professor Frank Chen, the former president of National Jiao Tong University and UCLA Double E Chair, as well as myself. Previous to founding Kneron's, I have held both R&D and manager experience in Qualcomm and Samsung. Our previous funding round was led by Horizon Venture and Qualcomm, Sequoia, as well as strategic investors like Foxconn, Winbond, and MXIC also on board. Over the past 2 years, our technology and business impact have gained quite some recognition from both the academic and business world. The paper on our core reconfigurable architectures was featured on Nature Electronics. As of this year, it has also been awarded the IEEE Darling Award, which is the highest honor in IEEE CAS Society. And in Gartner's very first report on AGI, we are featured as one of the key providers. On this recognition, we have continued to advance toward ever more lightweight and high efficiency hardware design, which are, once again, the core enabler of AGI. On the hardware front, Kneron is a pioneer by many counts. Kneron was one of the first companies in the industry to develop AGI chip, unlike other companies that develop coprocessor or computing stick as a supplement to traditional computing. Kneron was the first to define a complete and independent AGI SoC that connects multi-sensor and independently complete AI processing tasks in IoT device. In 2017, we delivered a first generation AI chip to Grid, which is the largest air conditioner providers. Kneron was the first commercialized reconfigurable hardware technology in the industry. We have conducted extensive in-depth research and reconfigurable technology published paper in top journal and conference. And we received patents to those technology as well. Reconfigurability allows our NPU to support image and speech recognition at the same time, thus achieving a higher energy efficiency ratio compared to traditional architectures. As of today, in revealing our next generation AI chip, Kneron is now also the first company to commercialize InFord with minimal precision loss and to commercialize transformer for advanced time series processing. And finally, Kneron is one of the few AI companies in the industry that is capable for providing full-stack integrated software and hardware solution. Kneron has developed several lightweight AI algorithms and received certification from authority allowing customers to easily integrate our solution and arrive first to the market. For 3 years in a row, we have released one chip every year, all of which have commercialized with customers in the field of smart home, AIoT, security, and vehicle. Some of our customers include GREE, which is the largest air conditioner provider, Avantech, which is the world's top industry computer provider, as well as leading Japanese car companies such as Toyota. Cost and performance balance are the foremost critical factors of Edge AI chip commercialization. Thus, instead of pursuing high power specs, we have worked to optimize computing efficiency through structured innovation. According to the survey conducted by the UC Berkeley computer scientist Kurt Cursor in March this year, the KL720 chip achieved the same level of energy efficient ratio as some of other most prominent AI hardware solutions. But note that we do so with much lower processing node requirement, tapping out the previous generation KL720 with the 28nm processing node, whereas the competitor tap out at the 12 or even 7nm in order to achieve the same result. On the one hand, this demonstrates Kneron's leadership in NPU architecture. On the other hand, it also means that Kneron produces high-performance chip at a lower price, given our solution superior price leverage. And today, I introduce our next generation AI chip, the KL530. The KL530 contains a brand new NPU design featuring multiple new functions and designs, including intelligent ISP to optimize image quality through AI algorithm and integrate AI, AEC, AWB control, and also the RISC-V, and which is an open source CPU, and also optimize tool chain compiler, enhance the security mechanism, and also ultra low power. But above all, there are 3 features that I will discuss at length. First is our next generation reconfigurable NPU, the KDP530, and also the transformer time series and spectral processing, as well as high-speed accuracy input processing. Also note that the KL530 is our first chip planned to be the automotive grade. Let's start with the KDP530 reconfigurable NPU, because NPUs are the core feature of any Kneron hardware. This is the architecture diagram of KL530. It is a highly integrated chip, including the CPU, GPU, codec, ISP, and LPDDR, and many interfaces that can independently complete AI tasks according to many scenarios. KDP530 NPU adopts a brand new architecture that enables the KL530 to have multiple times and computing compared to our previous chip, while maintaining the same size as our lightweight KL520. Compared to the KL520 and KL720, the newest chip KL530 has 2 times the level of energy efficiency, and its computing efficiency is increased up to 10 times. And aside from our own chip, here you may see a comparison of the KL530's compute efficiency side by side with the other AI chip on the market. In this example, all chips are running the same AI models, ResNet and Tiny Euro v3, and measures for how many frames they can process per TOPS operation per second. So as to obtain an apple-to-apple comparison, it then becomes clear that the computing efficiency of KL530 is significantly higher than other AI chips. And this efficiency, the KL530's new NPU, has been able to achieve thanks to our 4-bit data processing. The KL530 is the first AI chip to be commercialized that supports 4-bit data processing with the same level of accuracy as 8-bit and 32-bit data processing. We can represent data just 4-bit as opposite to 8 or 32-bit with almost no loss in precision. The data throughput efficiency increased by 8 times and 2 times respectively compared to 8 and 32 bits. And the amount of times needed to process data becomes half compared to chips supporting 8-bit or 32-bit data processing. This is done by the implement instruction set that compress the data. Part of the instruction set is done on the software layer, and part of it is done on the hardware layer. This means that KO530 can support higher frame per second with lower hardware specification and lower power consumption. On top of that, it can simultaneously detect more objects at any given time due to its higher computing speed. The KO530 is also the first AI chip to commercialize with the ability to support transformer, which is in itself a whole new class of artificial neural network. Using hybrid transformer and CNN processing, we are able to increase the accuracy of inferencing result due to transformers' unique characters. It beats CNN in existing language processing model as well as most image-based models thanks to its two key features, temporal and spectral image processing. Let's start with the temporal image processing. Transformers have an add time dimension consideration when they do inferencing. CNN are good for processing single frame, such as face recognition, but not good for processing continuous frame, such as behavior recognition, and also some car automotive application. Whereas CNN can tell between a cat and a dog just fine, and a hug, like two people with locking arm, and also a fight, also two people with locking arm, could look like exactly the same for a CNN. On the other hand, a transformer will better be able to tell between a hug and a fight because aside from consideration of the spectral dimension, it also considering the time dimension. For anything data that involves the time series like language processing, behavior recognition, or automotive application, it's better to be done with a transformer. Transformer accuracy is 30% higher than CNN for continuous frame. Thus, they are good for taking frame of raw image data and making better sense of them as a continuous events. On top of the temporal elements, I also want to talk about the spectral aspect for transformer. Transformer make inferencing historically. CNN make the inferencing based on the key features such as the eyes, mouth, and ears to determine the identification for an object. So say that, for instance, wearing a mask could be a challenge for CNN's ability to recognize a person. On the other hand, a transformer assess all features historically. In the automotive use case, the accuracy afforded by this historic inference could be life-saving. For example, if a car approaching a historically across a trunk that has an image of the mountain print on the side, and a car using a CNN could in fact infer that the trunk is a distant mountain. However, a car enabled by a transformer could be able to historically make an inference based on all nearby features and infer that the trunk is a trunk. Now, before I introduce the application, here is another key aspect of Kneron offering that must be considered. As I mentioned from the start, Kneron is a full-stack edge AI company. Our key hardware work alongside our software tool chain and, very importantly, our edge cloud platform to deliver streamlined end-to-end AI feature. Our edge cloud AI platform has four characters. First is edge AI equipment are connected to the cloud platform to combine the computing efficiency and security advance of edge AI with the flexibility and scalability advance of cloud AI to build a future-oriented edge AI network. Second, the NEO platform can realize cross-terminal, cross-network, and cross-application cooperation. This allows different sensors and clouds to interact and realize computing power sharing as well as storage sharing. Third, the open AI platform attract AI application developer, chip vendor, equipment supplier, and service operator join together to create an AI ecosystem. Fourth, through edge cloud cooperation, the processing data is stored, analyzed, and managed in the cloud to achieve smarter control and humanized terminal AI application. Based on the NEO platform, we have also delivered new application scenario and business model that enable the fleet management, traffic management, remote vehicle security alarm, remote security device communication, and remote face registration for access control device. To Neo platform service, Kneron charge the subscription fee from solution provider, corporate, customer, and user. We also enable developers to create their own application through the platform. Neo has entering into beta phase as a Q1 this year, and it plays an important role in realized number AI use case. This says I introduced the core Kneron application. Kneron's chip has already widely used in AIoT market, which is a market with billions in potential, range from home to utility to manufacturing. This building-in AI chip in the device brings richer function and user experience while avoiding cost and power consumption issues. Here you can see an example of Kneron full-stack hardware and software offering in the access control. Registered users are granted access to the entrance just by walking through the image sensor. And as they are given access, their temperature are also taken for pandemic management. The inference result can be desynthesized and sent to the localized edge server. On the automotive driving front, Kneron is tapping out the auto-grade chip that will be eligible for EV, AV, L1, L2 pre-market. The KL530 being the first of them. We have case with several automotive OEM and the MIH EV platform spun off from Foxconn for L3 and L4 and L5 segments. We also have kickstarted our long-term preference for the ongoing pre-research for the aftermarket. Over the past 2 years, Kneron has already tested out the non-auto grade chip in the aftermarket with success, with a partner like such as Automotives and Foxconn and Zhongxin Bus. The aftermarket has much shorter design cycle, talking on the scale like a year rather than 3 to 5 years. Over the other hand, between the vehicle pre-market and aftermarket, a lot of ADAS and DMS functions overlap. Thus, Kneron is now taking on the auto-grade market. This is the roadmap of Kneron's AI chips in the vehicle. Beyond the KL530, we also are tapping out the KL730 and KL750 in the forthcoming years. And the computing power will go up to the 4 TOPS. Many of them may think that it's very low compared with a solution with hundreds of TOPS. However, we have concluded on low spec because, for one, Kneron chip can be embedded into the camera for distributed computing instead of being the central box of the old cameras. Second, for L1 and L2, 8 TOPS satisfy most of the requirements. And in the use case demand higher computing power, Kneron's chip can also cascade to serve the need. Looking within the vehicle, one of our automotive applications is the driver behavior monitor, detecting a myriad of behavior such as talking on the phone, distraction due to exhaustion, or drinking, which is the key when it comes to the autopilot phase of automotive driving to ensure driver, pedestrian, and traffic safety at a time that switchovers can occasionally be necessary. Looking outward of the vehicle, we also offer an advanced driver assistance system, which detects road objects such as other vehicles, pedestrians, obstacles. They are distance aware from the vehicle as well as their acceleration and deceleration with regard to the vehicle. Our hardware and software offerings alongside the Neo platform enable safer, more efficient driving, particularly in urban settings. Our lightweight solutions are able to go inside a myriad of sensors to detect various angles and blind spots surrounding a vehicle. The result inference informs not just the vehicle's decision, such as lane keeping, but are also passed to coordinate time-sensitive issues with other vehicles. Loss inference and independent vehicle signals are also passed on to roadside units for more synchronized traffic coordination, such as in this case, allowing an ambulance to smoothly pass through a closed road without comprehension or delay. On this note, we are already developing a number of exciting new applications with partners and customers and look forward to sharing more of Kneron's technology with the world. Thank you for joining our latest update announcement, and I will hand over the mic for more expert insight coming up next.
Thank you, Albert, for introducing the KL530's pioneering features and ongoing Kneron projects. For those who are interested in more information, please visit kneron.com for public product specs or reach out to us via the website's contact form. Next up, we'll do a deep dive on a key topic of today, future automotives. What does it take for the industry to go from L0 to L5 fully autonomous vehicles? Moderating this panel will be Todd Weiss, Managing Editor from Enterprise AI. Todd, please take it from here.
Hello and welcome to Kneron's Future Automotives from L0 to L5 panel discussion today. I'm Todd Weiss from Enterprise AI, and welcoming our panelists today, Jody Shelton, the co-founder and CEO of Global Semiconductor Alliance, and Pei-Ming Chen, the president of Winbond, and Phil Chen, the general partner of Race Capital. Welcome, everyone.
Thank you.
Thank you.
Very good. So let's get started. We have some great questions here for the panelists. On this discussion, one of the things that we wanted to talk about was sort of a little bit about the vehicle semiconductor overview. Jody, I have a question or two for you, if that's okay.
Okay.
What can you talk a little bit about what are the market trends of auto use chips? The thing that caught my attention about this is that chips for autos are large, and I wonder, are they getting smaller? What can you tell us about that?
Well, obviously, cars are are supercomputers, right? We've known that for a while, and are really now differentiated by electronics and software, and then that integration of the software and hardware, I think, is becoming important. And I just think, in general, the automotive market is exciting. I can remember many years ago hearing about the automotive market in Munich. We used to have this event, so probably backtrack 10 years, and I guarantee that half of the audience was sleeping when we talked about automotive. So the market has definitely changed, and it's an exciting one. It's an exciting one for a lot of the big players and a lot of the smaller ones as well. And I think that the car companies now understand the importance of electronics. We just recently saw, for example, that Ferrari named a former semiconductor executive as their CEO. So Benedetto Vigna, who came from ST Micro, is now the CEO. You see Tesla, that has an entire hardware team and developing chips. And you hear from Ford CEO Jim Farley all the time about how important that this market is. So I think that the megatrends we know about autonomous vehicles, we know about electric vehicles, mobility, connectivity. So I think that this is really presents a huge opportunity for chip companies. We think that this market's going to grow from about 40 billion in 2019 to 200 billion by 2040. So this bodes well for the semiconductor industry in general, and many, obviously the companies on this call as well.
Okay. Let me ask you a quick follow-up about that. Some people think the autonomous driving market is currently experiencing a cool down. I don't know if it's market saturation or it is the problem with getting chips nowadays. I guess I wonder, is that something that you're familiar with and you can talk to a little bit about?
Yeah, I mean, I think that the autonomous market is still very hot. I mean, everything right now is so dependent upon getting chips. I mean, you've seen, $2.5 billion from Ford coming out of their revenues based upon the shortage. So I think that that's probably the bigger problem. I mean, there's been so much investment into autonomous, like $100 billion of investment. So I think that we'll see how it all turns out, but I still think it's a very hot market for the chip companies.
Okay, thank you. Pei-Ming, I have a question for you. Yes. Autonomous driving technologies, what are the respective roles of cloud and edge AI today in autonomous driving? Can you talk about that a little bit? These are such hot markets. It's interesting to see how they're now getting involved more and more with the automotive industry.
I think it is quite fantasy about the progress of the autonomous driving. You can see when Tesla just launched that, people were surprised, and however, when people to see more and more demo, and even there's a lot of accident happen, but it doesn't affect the people like it. And I did not see any slowdown momentum is going on. And however, during these days, I found that more and more semiconductor guys are thinking autonomous driving is quite like, we can say it's a computer on the way. So people try to engage in the autonomous driving, and all the people in semiconductor, in the system maker, we get investment in that and try to together to pull up. And user side, from the driver side, people enjoy that a lot. Actually, you can prevent a lot of small accident, and also for the long range, you can even relax yourself. So I think it's quite a fantasy thing, and still got a lot of momentum and investment to focus on.
Okay. All right. Well, thank you very much. Phil, I have a question for you. What is the most major barrier to realizing L4 to L5 autonomous driving in terms of technology, infrastructure, regulations? I'd love to find out your thoughts about this, because these are the challenges to the hardest part of autonomous driving.
Yeah, I remember looking at all the autonomous driving companies. I want to say maybe 2017. I would say that was maybe the peak of autonomous driving investment, where you could, not just all the big companies, but all the startups, they quickly went from L0 to L3, and then that demonstration showed investors, if we move at this pace, then we could get to L4, L5 quickly. And I'm just kind of comparing this autonomous driving problem to, in my previous firm, we invested in DeepMind, which built the engine for AlphaGo, to acquire them. And even, there's this whole conversation around narrow intelligence and then general intelligence. Of course, there are many tasks that we can categorize as narrow intelligence, and all the machine learning, all the stuff that you do learning in the cloud, can be quote solved, right? And so the question is autonomous driving, a narrow intelligence problem or a general intelligence problem?
What is the difference between narrow and general intelligence? Could you just describe that?
Yeah, just quickly. I mean, it's just general intelligence. It's, of course, it's, humans have general intelligence. Whereas, if you, in a narrow intelligence problem, you solve like say chess, teach a computer how to play chess. Can that, for example, computer transfer that learning from chess to driving, right? Is that knowledge transferable, right? That's one tiny example of narrow and general. Whereas chess is a bounded problem, driving seems to not be as bounded. It's bounded, but is not as bounded as the chess, right?
Interesting.
And so, going from L0 to L3 and then kind of covering, like, you could quickly build a machine learning model that could teach a car to drive, maybe 80% of the conditions, right? But the final sort of kind of last mile, 10, 20% is the difficult part. There's so many exceptions. There's just really so many exceptions that
in a way,
we need a spectrum.
I was going to say, in a way, when you were speaking about that, it made me think of Moore's law. It took, what is it, 30, 40 years to get to a certain size chip, and now to make them smaller is getting harder and harder and harder. It sounds like the same sort of analogy there.
Yeah, but I would make it even more dramatic. I mean, well, the first thing I'd like to say is, if there was a spectrum between 1 to 10, where 1 is narrow intelligence, 10 is general, where do we categorize L5 autonomous driving? It's probably a 3 or a 4. It's not completely narrow intelligence, right?
Okay.
And then the second thing is, I'm just quoting a physicist, David, sorry, I forgot his last name, on the beginning of infinity is, I mentioned this, Todd, because you talk about Moore's law is, if we wanted to build, a brain, a semi today that was equivalent to our brains today, it would really take, the size, of a city to build one chip that simulates one brain, right? And if you wanted to be able to compute the whole world, you would consume all the resources on Earth to compute. And so that's not to say that, with that you can solve L4, L5, but that's definitely overkill. But yeah, I would just say from a software point of view, hardware point of view, there are quite a lot of changes to L4, L5.
Okay. Pei-Ming, I have another question for you real quick. Are there any specific semiconductor technologies that will become the key enablers of an autonomous driving? Are there things that we really need to keep developing to make autonomous driving something that's going to be easier to do?
I think from the technology wise, I can say in the new level 4 or level 5 autonomous driving, actually there's a more and more sensor. So which means more and more CPU and PU will be necessary. And some AI calculation will be localized, which means behind each sensor, could be a lot of AI activity done by the local processor. So in that case, we need a low power AI performance chip, and we need some very localized rather than a big one, big CPU, big DSP to handle all the AI stuff. So when you make it localized, so you need a small die size and lower power consumption die to be invested. So that will be the very important technology trend to support the autonomous driving.
Are these going to be difficult to reach because it's getting harder to do L4 and L5? Is that what we're waiting on, the technology, the chips, the semiconductors themselves?
Yeah, I think it's really difficult to make it very, very low power and very small die size, because there's a lot of sensors compared to the past, maybe 100 sensors, but in the future, maybe thousands of sensors. So still a long way to go, but we see progress year by year, and actually compared to Moore's law, it goes very quick.
Okay, very good. Jody, I have a quick question for you. Which semiconductor products are most cogent to future vehicles? I guess we're talking categories and sizes, things like that. What kinds of things can you talk about that would help us understand about future vehicles? What's still to come that will help get them on the road?
Well, I mean, I think that these gentlemen are probably, better equipped to answer that. But I mean, I think that, high performance central compute chips, such as domain controller units and sensors, is probably one of the fastest growing areas that we think about, and expected to, rise by about 12% from 2025 to 2030. So I think that there's also the, ECUs as well. So, I mean, those are two areas. And again, I would imagine these gentlemen can talk about that a little better than I can.
Well, all right. Let me ask you then another question, if I could. The market size evolution for vehicle-related semiconductors, the volume and growth, is this something that, are we reaching a plateau? Are we still at this point? Do you see this soaring? I mean, we're seeing governments, including our own, saying that at some point, electric vehicles will be the only vehicles we may see sold in our country. Other countries are saying the same thing. Does this mean that the market size for these kinds of vehicle-related semiconductors is just almost effortless, or excuse me, limitless? That's the word I'm looking for.
We hope so, right? But no, I think it's a huge market. And again, I think that that's why you see you not only see the big guys going after this, but you see so many startups around electric vehicle markets. So yes, I think it's it's a huge market. It's expected to grow, by 12-fold over the next, probably 10 years. So, it's an incredibly important market. And you see all kinds of activity around electric vehicles. And of course, if you look at the history of the automotive market, back in, the early 1900s, there were probably 250 car companies around, and then it pans out in the US that about 3 survived. So I think that will be the same case for the automotive companies. So I think that there will be less people or less companies ultimately to serve. But not only do you have US putting a huge emphasis on it, but you have China, you have Europe. So it's global, and the opportunities are huge.
All right, very good, thank you. Phil, I have another question for you. LiDAR. LiDAR is something that some people are saying maybe it's not necessary anymore. What are your feelings about that? First of all, why is LiDAR used, and why is it important, or is it not important today?
I think that's what Pei Ming was referring to, just the number of sensors that needed to be added on the cars to get L4, L5. But there definitely are differing opinions here. There are autonomous driving companies that just want to rely on computer vision and machine learning and believe that, they can go from L3 to L4, L5 just from, normal cameras. Other companies have taken their approach where they absolutely need LiDAR to map and sense and be able to recognize patterns and things. And so, I would say there's 2 very kind of, maybe more than 2, but like in terms of LiDAR, there are definitely a very clear difference of approach where hardware manufacturers, they want to integrate LiDAR. They think it's a necessary component and sensor. But then, some of the software guys on the other hand of the spectrum, don't think it's necessary. They do believe just by computer vision and machine learning and chips on the cloud or on the edge that can achieve it. And so I just want to lay out, I don't have a particularly strong opinion here.
Okay.
But those are the opposing views.
Okay, very good. All right, Jody, I have another quick question for you. And that is, let's talk about supply chain for a moment, okay? How is the supply chain responding to the chip shortage and its causes? And we're talking about a supply chain issue here in the US. We're talking about one all over the world. President Biden is taking efforts to help solve some of these supply chain problems, but those are in ports. I don't know if that's really going to solve the chip problems. Can you talk about that a little bit?
Yeah, I think that it's important to really understand, what the reasons behind the chip shortage. I think it's a little bit different than some of the other supply chains. In fact, I really almost hate to use the word supply chain when you talk about semiconductors because it sounds so simplistic. Oh, can't we just fix this part of the supply chain? When, as you know, it's really an ecosystem that everything is so incredibly dependent upon. On each other. But there are a lot of really great things that happened that caused the crisis. Okay, so first was the rapid move to digitization. So in about a 6-month period, we experienced 7-year move towards digitization. That's just, that's unprecedented. It's just hard to even imagine how quickly that happened. And then in addition to that, you had all of these new technologies that we've been talking about for years and years really come to fruition, things like IoT and the AI, 2 of the areas, 5G. And then the third great thing that happened was that there was a V-shaped recovery, economic recovery, and a big V-shaped recovery for the automotive industry. And I think that those things combined with things like the China-US trade tensions, natural disasters, as well as declining CapEx. So not only do you have, in 2019, you had declining CapEx. Okay, so about 15%. And if you take out the foundries from that, it was really like a 40% decline in CapEx. So in addition to that, you've had years and years of declining CapEx in the legacy nodes. So that's where a lot of these shortages are coming from. I mean, if you just look at what Apple announced a couple of days ago, I mean, it's a shortage of 2 chips. So it's not just the major chips that are important, but it's all the chips that go around them. And a lot of those are dependent upon legacy nodes. So I think that a lot of good things happened to cause the crisis. I think it's also important to emphasize what didn't cause the crisis. A lot of people want to say that, well, it's because we don't have manufacturing in the US. We only have 12% of manufacturing in the US. But that's absolutely not what caused this problem. It's demand caused the problem.
Well, demand because of the pandemic, everybody working from home,
right.
Of course, but also what about the just-in-time deliveries kinds of things, of supplies, components to build things, even semiconductors? I mean, we're still talking about all the things that you need for those things. Were supply chain issues in terms of just-in-time manufacturing, right. Companies, factories shut down because of the pandemic and shutdown orders, people got sick. I mean, all those kinds of things. It was such a mass amount of events for every industry, I can imagine.
That's right.
Yeah,
that's right. And if you look at the automotive industry, literally in March of 2020, from March until May, I mean, they completely closed down. There's stories about, deliveries pulling up to their gate and basically turning the chips away. So I think that, I mean, of all groups that have learned their lesson from this this latest crisis, I think it's been the automotive industry, that you just can't work that way with semiconductor companies. There's got to be a partnership. There's got to be a collaboration. There has to be a working relationship between the automotive industry and semiconductors, and that's never been the case before. I mean, things have really, the automotive industry has really changed, and I think that we're seeing that. I mean, we've got lots of these automotive companies that are now members of GSA, companies like Tesla that are on our advisory board. I mean, so they know how important chips are now, and this just-in-time thing is just simply not going to work when you're talking about something as important and critical as a semiconductor.
It's almost like an analogy. I don't know if this even fits, but it's like fresh meat. You get fresh meat sent to the stores, and it doesn't have a long shelf life. So chips are kind of the same way. You can't just turn them away. And I guess, yeah, this is something that a lot of people are going to be learning about. I wanted to ask you a follow-up question too, and that is, should the U.S. be building up a domestic semiconductor supply chain, something that helps us, maybe government assisted, to help build an official supply chain so this kind of thing doesn't happen again? I mean, it could be a horrific winter storm with climate change. It could be, power outages down in the South if there's a plant there. It could be so many different things. Should we have an official discussion of supply chain for IT and for semiconductors?
So I think that this crisis has definitely uncovered some structural issues with the supply chain. Okay, so with the concentration of manufacturing, but natural disasters can happen anywhere, and so I don't think that having a supply chain or an ecosystem in the U.S. is going to necessarily cure that problem. I mean, in our industry, we have really fueled so many end markets and have been so important to bringing great products to life. And our industry executives have long, been wringing their hands about, oh, we don't get the recognition we deserve, all these staggering R&D costs and the complexity of chips, and no one really understands things. And I think that what this, one of the silver lining is that now people do understand things. They understand the criticality of semiconductors, and that includes policymakers. So what we hope doesn't happen is that policymakers go too far. Okay, I mean, it's a real risk. I mean, if you talk about trying to replicate an ecosystem in the US, by the way, Korea has an ecosystem, Taiwan has one, China wants to have their own. Russia even announced recently that they're going to be investing in their semiconductor arena so that they can have their own ecosystem. So can you imagine all these ecosystems being replicated? And all over the world. I think that that would lead to further decoupling, which is what we've already seen happen to some extent. So our industry has thrived off of global collaboration. So I would hate to move away from that. At the same time, I think it's legitimate for the US government to try to incentivize a more resilient supply chain. Definitely, try to incentivize companies like TSMC to come here and Samsung, which, by the way, they've announced that they are. So I think that that's all legitimate. It's just that we hope that it doesn't go too far. I mean, governments definitely distort markets. They don't understand this market. It's a very, very complex system. And I think that the fix will come from the industry. It won't come from government.
Okay, very good. I have one last question and then we'll finish up our discussion. Phil, I guess what I wanted to ask you about, in the global world of competing stuff that needs memory, including AI and crypto, it's a tug of war between what is the most lucrative application, which will decide how the industry plays out.
Yeah, I would say, as everybody was alluding to, there's just so much demand for, semi chips. And, I would say the hot markets right now, of course, it's, anything that has to do with AI, and that requires, GPUs, of course requires CPUs as well. Gaming is an industry that's, eating a lot of this chip demand too. Gaming is such a hot topic in any way imaginable. It's so hot that China had to ban video game playing right. There's just so much demand. And then I would say crypto mining as well. Crypto mining, it's the same GPU you use for mining a lot of the crypto to mining, not mining, but using for machine learning algorithm. And so, all this cloud compute that's of huge demand, I would say AI, gaming, and crypto, which are immediately profitable, right? Versus, autonomous driving, where we can't achieve L4, L5 yet. The business model is not clear, right? And it's, the big companies who have a, longer term view can afford to invest in this. And so I would say in the hierarchy of, hierarchy of kind of demand and needs, I wouldn't put autonomous driving as, at the top of the list where chip manufacturers are serving, and even when we talk about cars needing, chips, of course, it's not so much the autonomous driving chips we're talking about. We're talking about, MCUs and, other kind of more high priority rather than chips, for machine learning and autonomous driving. And so, I would just say that, general needs of cloud compute, AI, gaming, and crypto mining, these are kind of the immediate ways that have clear business models, people are profitable. And so, naturally that they'll get kind of first digs on this,
all right,
on the supply chain for semis.
All right. Well, very good. To all the panelists, Jody, Phil, Pei Ming, thank you so much for your time and for helping us with this panel. We really appreciated it.
Now, with these insights from expert insiders on what to anticipate along the road from L0 to L5, from both high-level AI and semiconductor perspective, we understand that on top of the semiconductor, there's a lot more infrastructure and supporting solutions that must fall in place to bring about fully autonomous vehicles. Among these infrastructure, AI platforms for collecting, managing, relaying inferences, ecosystems to foster the proliferation of AI application developments. These two could have a role to play, as Albert mentioned in the keynote. This said, our next session is a fireside chat with the founder of one of the most influential open platform businesses in the world to explore the possibilities that exist where AI meets open platforms. And moderating this panel will be Ben Wadeke, reporter from AI Business.
Hello, and welcome to this fireside chat between myself, Ben Wadeke, reporter from AI Business, Albert Liu, the CEO of Kneron, and YouTube co-founder Steve Chen. Today, we're talking about AI meets open platform. specifically at a time when production and dissemination of audio and video content was an expensive and exclusive enterprise largely controlled by hands of a few media players. To tackle this, Kneron recently launched an AI edge platform named Neo, where they made available a pre-trained AI models and AI deployment tools as a means for developers to more easily create and market AI applications on the platform. Albert, let's kick us off with you. Talk us a bit about Neo and some of the major wider challenges you're seeing in terms of acceleration of AI edge deployments.
Sure, Ben. For Neo, actually, this open platform has two main purposes. The one purpose is trying to make people to define their own AI, right? And the second purpose is trying to make people to define their own interconnect network, subnetwork, and also based on that subnetwork, we can have our own pass service and also own subs service. So let me explain a little bit more for the first one, right? I think right now the AI are like defined by the big player like Google or Facebook, right? So if the AI application only limit by voice recognition or face recognition or even like automotive application, obviously it's not, right? So some people, they might need AI for like watch their dog. And also some people might need the AI to watch their backyard, right? So, but the big player might not like develop those AI application based on those like so fragment application. So the first application for Neo is we do a pretty similar stuff like Google like Google Store or the the Apple App Store, right? The App Store like make people can develop their own app or their own AI application and submit and sell those applications in our Neo platform. So we try to simplify the development process for AI and make people can define their own AI application. That's the first purpose. And the second purpose is Neo, you can treat that's encrypt, like combining blockchain and also the AI platform together. So every people can define their own subnetwork. So based on that subnetwork, maybe we can install like dash cam in my car. And based on that dash cam, there's an AI engine inside, and we can determine if I'm a good driver or not. And if I can get a pretty high score, proof like I'm a good driver, then I can, based on that digital access, to negotiate with the insurance company to give me a better discount, something like that. And the same application can also apply in the smart home appliance, like to monitor if my family in my home, if there's some like abnormal behavior happen, and send me the instant warning message. So those are the two main purposes for Neo.
I'm sure you are a good driver. We wouldn't need to tell a user system for that. Steve, I want to come into you on this because obviously you founded a platform from very early ages, and it's grown into this behemoth monster of a titan in this space. What kind of elements are required, in your view, for success of open platforms?
Sure. I mean, I think at the time, and this is years ago when we started YouTube in 2005, right? It was still something very new. It was still trying to just break the ground on whether or not the internet could be sufficient enough. It could be sustainable to be able to build a streaming platform for video using just the internet that we knew back then in 2005. Broadband penetration was just starting to reach to masses. The upload speeds was still much slower than downstream speeds, and so we were still dealing with a lot of the issues in just whether or not the internet itself could be scalable enough to be able to be distributed. And this is a lot of exploration in the cloud space at the time. So this was before Amazon AWS, before a lot of the Google clouds came out. And so this was still at a time that when it was still building it onto our own data centers and starting to roll out. But I think most importantly was on the backend side of things, on the software side of things, was really to be able to pull together all the actual open source and a lot of the available libraries out there and to be able to compile it together into I think most of the work that the engineering team did at YouTube was really to take a look at what was already open source codecs out there for video, codecs out there for audio, being able to combine that all together with all the different incoming different videos and audio streams coming together, transcoding it into one format and being able to show that onto just one browser, be able to stream it to all browsers without having to download another application to install it before you use the app, to use the service. And I think that much of what we were doing back in 2005, the success of YouTube was to be able to use what was openly available out there to be able to glue it together and to be able to use it in one cohesive way. I think since the acquisition by Google in 2006, it has continued down that track, and I think that Google has really taken kind of at the forefront of defining what the new streaming codecs are going to be, what the new versions of, and they've been open about it, such that now it's much easier to be able to get open source code out there, to be able to use the same libraries, to be able to transcode anything that you have on your cameras, anything that you have on your phones into something that you can see on YouTube. And so I think that many changes along the way, but I think in general, this sort of revolution about thinking about using closed source backend code into now using really just open source, and then whatever you've actually got built, you can open up, and Facebook is doing it, Microsoft is doing it, Google is doing it, sharing a lot of what they built internally and opening it up for others to be able to use. And just collectively with everybody in the cloud using these services and adding back into it, it just makes it a lot easier to be able to get something like YouTube off the ground now.
And Steve, on that, you're not just the co-founder of YouTube, you've gone on to becoming investing. And that brings me on to my next question in terms of, there's so many, you picked up on so many of these platforms are coming up now, and the move between open and closed. What does someone have to do to stand out to you as an investor in this space in terms of their platform coming to you and saying this would work? What does Albert have to do to get Neo in front of people? What's your advice on this?
Well, I think what's really exciting to me is in 2019, I physically moved from Silicon Valley after moving there in 1999, having been there for 20 years, sort of picking up just my bags, but as much as myself, but the entire family, and moving the entire family to Taiwan, which is where I'm living and where I have been living for the last 2.5 years. And what I've been really interested in has been trying to see what it is that was kind of magical about Silicon Valley that's made so many of these, trillion-dollar companies emerge from such a small ecospace of just within 10, 15 miles from one another. We saw all the VCs that we were talking to YouTube. We were able to talk to Yahoo. We were able to talk to Google about an acquisition that was just merely minutes away from one another physically, right? And I think that one of those things is there are so many of these Asian Americans from Silicon Valley that have been successful, yet somehow some elements were missing here in Taiwan. And so one of the biggest things for me coming back to Taiwan was to be able to see what was missing and what were the things that we could do to maybe spark off this new wave of startups coming here from Taiwan. But I think one of the most exciting things about meeting Albert was that Albert's one of I think the same thing, a company that is multinational at its very, very beginnings, from having roots both in Taiwan as well as in California, and then expanding with investing from all over, investors and VCs from all over the world. And I think that from just my own personal background, this is something that I would love to be able to throw my weight and any of my connections behind, just to be able to see this grow and to be able to take lessons from there and spread it across as I'm settling down here in Taiwan.
Thank you. And speaking of multinational, Albert, I want to come to you because you and I spoke in September on your work at Kneron, and one of the things that struck me is your work in the automotive space. And you're based in Silicon Valley, you have that outreach there with Steve and everything in Taiwan, but your work in Japan is something that struck me as being absolutely fascinating, because you have, you'll be able to tell our audience, of course, but talk us a bit about your work in the automotive space, and particularly, your kind of how you entered Japan and how you're working there.
Yeah, as you know, like the main core definition, or the core confidence or the secret sauce of Kneron is a AI chip, right? We pretty much is building edge AI, so trying to bring the AI from the cloud into like all judgment in the edge side, right? So we pretty much we build a pretty powerful and low power AI chip with the core technology we call the reconfigurable architecture. So that reconfigurable architecture pretty much win the IEEE Intel Award. So it's like we're proven not only for academic but also for the industry. So with that architecture, it's a pretty unique AI chip or edge AI engine can simultaneously to run like video-based AI or voice-based AI or image-based AI or 2D or 3D. So we start to enter Japan market through a supply chain called Automotives. They belong to Delta Group, and we all know like trying to enter the pre-market, the cycle is quite long. Also, we are also working with Fastcom to build an MIH platform, trying to go to the before market. But we expect it might take like 3 or 4 years long. But like we want to start to enter that industry, start from the aftermarket because the design cycle is shorter. So Otis is the company trying to provide a total solution with the dash cam. So dash cam is a camera keep doing the recording. So we pretty much enable that dash cam with the AI engine and trying to make the dash cam not only doing the recording, but also have some DMS, driver monitor assistant capability, or the ADAS capability, doing the car detection, lane detection, pedestrian detection, and traffic sign recognition. And one things happened is there was an accident happened in Japan. Is an old lady trying to hit the car by herself, but in the recording, because we have an AI engine, so it helped we pretty much cascade all the screen. So it's 30, 60 degree. So even that old lady hit the car from the backside, it was we're record and we're detected by the AI engine. So I think there was a news in Japan, and suddenly people realized how important the AI engine inside the car, even that's aftermarket, is. So that's the reason we start to have more. I think we have a more than 20% market share in the aftermarket DMS, AI-enabled DMS and ADAS in Japan. So that's how the story is going. But I think the reason we can achieve that is all thanks for the low power by battery. Like I think it's less than 1 watt and can be powered by battery for many months. AI engine. Yeah, and also thanks for our engineering team to come out some lightweight AI software. So we provide like not only the chip but also the software total solution together.
And Albert, on that, you know, Steve is based in Taiwan, and what struck me is you can't talk about AI chips without mentioning TSMC. You know, the YouTube of the chip world. Albert, how much do you want to kind of emulate them? Are they kind of the model that you're looking at and saying we want to be there? How are you viewing that?
For the whole supply chain, definitely Taiwan is an important place because the biggest foundry, TSMC, is based in Taiwan, right? And also not only the TSMC foundry, but also the substrate. The biggest substrate company are like Nanya and Xinxin. Those two are also Taiwanese company. And even the biggest testing and packaging, which is ASE and Spree, those two are also Taiwanese company. And I think it's also the same as Steve. Kneron right now has not only for San Diego base, but also we have a big operation site in Taiwan. And like the whole industry in Taiwan really watching us because they believe that AI or AI chip is the next big things. So we got great support from whole supply chain because of the strong relationship in TSMC, UMC, and Xinxin, Nanya, and also ACE. So even though right now we have a global shortage for chip shortage, right, or whole supply chain shortage, but I mean every company wanna bet the future industry. So even they are trying, like they have some difficulty, but they still keep supporting us. So quite luckily, we have enough of the quota till the Q3 or to next year. yeah, I think that's pretty great compared with other player in other country. Yeah.
And Steve, on Albert's case, you're watching the market in a really innovative way, because am I right in saying that you guys use an AI system to actually monitor potential investments ongoing at the moment?
Sorry, one more time. What was?
Yeah, so I was saying in terms of the market space, you're actually using a system to actually monitor potential people like Albert to invest in, isn't that right?
I mean, I think that it's one of the the multiple angles. Yeah. But I mean, I think that I think that my true interest is having known some of the challenges that we faced with what this exact solution provides. The problems that we were facing, it was very difficult to be able to work around this, and to be able to see it at the low power usage, to be able to see it transformed in the last few years. I think there's it's at the cusp of something new, and I think that what we're seeing here is just the economy scale to be able to get something out like this to be now in such a way that could be completely scalable. I think that it's a very interesting period to be seeing what exciting things are going to be coming in the next few years.
So in terms of if you were to name potentially interesting interactions, either of you, between AI and open platforms on an advanced technological or even a business level, anything comes to mind from those? Steve, I can see the gears working there.
Well, I was going to let Albert.
Oh no, Albert, either can jump in.
No, I think Steve want to reiterate that the reason drive him to investors is based on his own judgment instead of any of the AI engine. Yeah.
Yeah, I mean, I think there's so much potential here, right? I mean, I think to be able to have something get to a price point in which it is accessible, it is this accessible, and to be able to have the open source APIs out there to be able to have the access to the SDKs and continuing to be able to have these devices in everybody's pockets and everybody's homes and everybody's cars. I think that it's just going to be an amazing thing. All I know is that it's going to be some revolutionary big leaps are going to be happening in the coming years. I think I'm still brainstorming exactly what it is to be able to start my next company based on it. But I think this is going to be at the very heart of what's going to be coming next in the revolutionary technology wave.
And on that, I wanted to actually ask you, Steve, to impart some advice to Albert, because his team have grown considerably in this space in the last 12 months alone. Well, what advice would you impart to Albert and the Kneron team in terms of working in this space and going towards the next 12 months to 5 years?
There's a big difference between 12 months and 5 years. I think I'm much better with 12 months guess than 5 years. But I think that a lot of this is on the scalability of the hardware side, right? And I think that if you look at a lot of the reasons that I think even looking at just the big leaps that technology has taken in the last 10 to 15 years, it's still going to be, at the end of the day, what's going to trigger the biggest momentum is going to be the application itself, the application that we can't go living without. And so I think it's one thing that on the hardware side, on the back end side, it reaches a certain point, but until that software that comes out, that application that comes out, that really transforms how we've done something in some classical manner, but revolutionizes it, it's going to be that item that's going to be possible. It's going to be made possible by the economy scale of what we've seen with these chips. If we have an application like that, or applications like that, something as far as just even in the last 10 years, in which the smartphone has completely revolutionized to something that just came out as kind of an experiment to something that we can't see our days going on without. To be able to have devices like that and to be able to have the application, you really need the two to be combined together. And I think that we're still we're still on the cusp of looking for that application that we can't go without.
Mm-hmm. Albert, yeah, go on.
Yeah, I think the back to 2012. I think that's also the reason we want to bring the Neo to the market is back to 2012. When we were in Qualcomm, the cell phone chip, people keep saying that would that the need for the cell phone to have so high computation power need the so high end cell phone chip. I think the AI era, I will say that will be the engine for not only the software but also the hardware, is because I mean, when the cell phone has enough big computation power, it opens a box for some application keep coming out, because I mean the computation or the capability of the cell phone limit people's imagination. So because they upgrade the cell phone main chip, so and also open the cell phone app store. So I mean, back to 2012, I believe the main game in the cell phone are quite limited, right? But because of app store, people are start to develop so many like Pokemon Go or like so many games in the cell phone. I think the same thing for AI. Once you upgrade the hardware with the special purpose of the AI chip and enhance the computation power, then we have enough the open platform. Then so many applications will jump in, and that will be a next revolution for the whole AI era.
Mm-hmm. And on that revolution, you've just launched Neo recently.
Yeah.
But what's the plan? How do you see the platform evolving over maybe the next year to 5 years? As Steve said, it's a long time and very different.
Yeah, we want to enable the intelligence into all device. So I think every people watch some like science fiction like Star Wars, right, or even the Matrix or Terminator. So once your device become more and more smarter and they can communicate with each other and have their own judgment, the whole judgment will be even more mature or more accurate. For example, right now, if we only enable the automotive with a big brain, then the judgment for that car for those automotive might not be safe enough. For instance, if there's a car driving on the highway and if there's a nail in front of them, or if there's another car like driving across the street, because they cannot tell them or they cannot recognize them simultaneously, they might higher the risk for the car accident to happen. But let's say if in the future, like surveillance camera has their own intelligence and the car has their own intelligence, and even the sensor surrounding the car has their own intelligence, then even like when you are driving the car or the car was driven by their own AI engine, then the sensor can tell there's a nail in front of them. So the sensor can warn the main brain of the car saying, oh, if you keep driving in like your nail might be like got broken, got threatened by the nail, right? And if the roadside unit or the surveillance can tell there's a car is approaching you or a pedestrian approaching you, they can send a warning message to the car. So I would say once you enable the intelligence into all these to the science fiction, like Star Wars, like R2-D2 and 3PO are arguing each other, and they can have a better judgment and more accurate judgment.
Well, I look forward to it being like Star Wars, although I am a Star Trek guy, so who knows? Steve, in closing, Albert said he sees it going to more that space. In closing, where do you see this space going?
No, I mean, I think it's very much aligned with. I think it's one thing to see that vision, to see that picture, right? Of I would love to be able to see as you start pushing more intelligence down to the lower and lower layers. But I think it's still waiting to see how does this all interplay with one another as they start all communicating with each other, and you start having many more decision makers in the room about every decision. How do you actually? And I think it's just going to be again. I think it's. When you have this power, I think it's going to be the innovation, it's going to be the startups, it's going to be the technology that embraces all this together to come up with that next big step, right? And so I think it's I think we're starting to see all the prerequisites that are being slowly met here. Now I think it's a matter of how to actually harness all this together into something that's cohesive, something that we can all digest ourselves.
And Albert, any final thoughts?
I think we just open a box or open the limitation, like what happened for smartphone back to 2012. I think in 2012, the two major engine to drive the smartphone into what we experience right now is, I think, first, Qualcomm built a pretty powerful engine for smartphone, and second, Apple opened the app store for the smartphone. So that's the reason we bring the powerful AI chip like KO530, and also bring the AI platform, what we call the Neo. It's an AI engine combining with blockchain, which can have better communication or the limitation of the privacy between device and device. And also with the app store, app people can define their own AI. So we hope that we can drive our life more and more close to like the Star Wars science fiction's life. Yeah.
It's a space that we're all watching. I know we are here at AI Business, and it's something that we're really looking forward to. So if it does get like that, we're looking forward to it. Thank you both for your time.
Thanks.
Thank you very much, guys.
Thank you, Ben. Now that we've covered autonomous driving as well as AI platforms, both of which are important but specific aspects of AI applications, let's take a step back and look at the greater picture of AIoT at large. The billions of devices that will soon have become either connected to remote AI compute capacities or become directly empowered with AI hardware inside. Where are the next big applications and what is required to bring them forth? I leave this question to three technical and capital market experts in a discussion led by Ting Fang Zhen, Chief Tech Correspondent from Nikkei Asia.
Hi, everyone. This is Annie Zhen Ting Fang, Tech Correspondent with Nikkei Asia. It's my great honor to be here for today for the AIoT panel. Here joined with me are three industry leaders that we will discuss AIoT market outlook, its capital market, as well as its challenges and opportunities. Let me first introduce Bob McCooey, Senior Vice President with NASDAQ. Hi, Bob.
Hi, Annie. Nice to see you.
And also joining us with us is Ashley Flukas, founder and general partner with Flukas Ventures. Ashley, hi.
Hi, how are you? Thank you for having me.
Also, please welcome Kerr Zhang, entrepreneur in residence with Kleiner Perkins. Hi, Kerr.
Hi, everybody. It's really nice to meet you all. Thank you for having me.
First of all, let me kick off the panel with you, Bob. Could you please share with us a general market overview for the AIoT market in terms of growth and size, and what are some of the fastest growing verticals that you are seeing?
It's quite amazing, Andy, because everyone in the capital markets certainly wants to be an AI company, wants to be an AIoT company. I think that every day the market gets larger and larger. So we're talking now probably in the trillions of dollars of both capital that has been deployed, as well as commerce that is happening in the space. And so we see it in private companies, we see it in public companies, you see it from what would be considered old line companies such as the SAPs and the General Electrics of the world, to the $2 trillion behemoths like the Microsofts and Amazons that are certainly using them in their business each and every day. But the challenge really is to understand what's around the corner, and that's why it's so exciting to be here tonight to talk to you, or tonight for me to talk to you, because Kerr and certainly Ashley are right on the front lines of everything that's happening. I get to talk to companies on a regular basis as they are growing, as they're building new products and services, as fantastic entrepreneurs are building businesses in Zhengzhou and Suzhou and in Vietnam and Indonesia. But there are fantastic entrepreneurs building the next AI business all over the globe. And so I don't think we can really narrow it down to what the market size is, because the market size is it's the balloon that keeps growing, and it's I think the everlasting balloon that keeps growing in size, and I don't know that it ever pops, because it just is so large, and there's so many things, because every aspect of our daily lives is being driven by technology today. And so we're so excited by the companies that we see that are being created, and they really come in each and every vertical. They come from companies like iRobot, which changed the way that we engage with literally cleaning the floor of our house, to obviously companies like Tesla and SpaceX that are helping us to drive efficiently and take us into space, and every company in between. So that's what's so exciting. I think that's what probably gets Ashley and Kerr and I up every morning to do what we do, and to engage with the companies and the entrepreneurs that we are working with, because of the future that is all being driven more and more by the implementation of AI in every business.
Thank you so much, Bob. And Ashley, you have an investment portfolio of more than 200 companies, 200 startups. And in your perspective in AIoT market, what are some fast-growing sectors, as well as what are some growth drivers driving those growth?
Yeah, that's an excellent question, and kind of piggybacking off of what Bob said. Seemingly every major tech platform is leaning towards incorporating this as part of what they want to build. I think you're hearing a lot of words like metaverse, ecosystem, unified technologies, and AIoT is exactly how that's made possible. And so when you think of kind of the biggest categories, even though it touches every aspect of our life, we're thinking of wearables and personal computing devices, smart homes, smart cities, and even smart manufacturing. And some of the factors that are driving that, I think it's bottoms up and top down. Top down from these big tech companies that are putting out, particularly on the consumer side, all of these devices that are becoming essential to our lives and are smart, and kind of driving the consumer appetite for smart devices, more efficiency, faster services, and that's all powered by AIoT. And then besides those factors, you also have things that are burgeoning as far as governance. You think of some of the tech cities that are, or tech focused cities that are starting to lead initiatives, like different cities in the Middle East, Dubai, Abu Dhabi, and the emphasis on smart cities, which is only possible by having AIoT. So I think all of those trends together, from a consumer side as well as an enterprise side, you're definitely seeing a lot of trends. And I think it's driven by both consumer demand as well as what some of the major platforms that affect our lives are now focusing on as they seek to unify their products.
Thank you so much, Ashley. And let's together look at the capital markets. Bob, you have great experience in supervising and helping IPOs across the globe. Could you please share with us some of the key IPOs related to AIoT in recent years? And what are the market response and investors' response to those IPOs?
Well, again, I guess it really, Annie, boils down to how you want to define it. I worked with Facebook back in the day, and Facebook as a platform, as Ashley just indicated, is one that is doing more each and every day. I've worked with thousands of companies. I've been blessed to work with thousands of companies in my career. I was the person that worked directly with Tesla on their IPO. So the ability for these companies to come to market and be embraced is really about what the investor expects for future growth. So, today you have Ford and General Motors, and I think their market caps are $60 or $70 billion, and you have Tesla, and its market cap is $700 billion. And it's not that Tesla is creating more cars, or even has a higher margin than those others. It's what investors are projecting as going to be the winner in the future. And so they've placed their bet on Tesla. They've placed their bet on, Amazon. They continue to every day decide with their dollars as to who are going to be the winners and the losers. And that's one of the things I always explain to people as I work at a stock exchange, is that I don't set the prices. Investors set the prices each and every day, and they do that with real dollars. And at the end of the day, they're betting on which ones are going to be those companies that are going to change the world. And we're so excited that you can get tech companies, and I would be remiss if I started to rattle off just the tech companies that have listed with us this year, as opposed to those that have listed with us over the past decade, that are literally changing the way that business gets done. But at the same time, you have companies that are behind the scenes that have really transformed business. Amazon and their warehouses wouldn't be where they are today if they hadn't purchased Kiva Systems for $1 billion a decade ago. And the ability for entrepreneurs to continue to build and put more transistors into a microchip, to put more battery and capacity into every single device that we have. Those are the things that will continue to change our world. I was thinking about it when Ashley was talking, is the fact that, I don't use a remote control anymore. I use my phone. I literally can change the lights, turn on and off the TV, the volume, close the garage door. I can do everything from my phone. And that's just one aspect of what my phone can do. I said to my children a half a dozen years ago at Christmas, I put my wallet and my phone next to each other, and I said, if you were going to lose one of them, which one would you worry about losing? Of course, all of them care about the phone, because when you think about the internet, AIoT, fundamentally, it comes down to a lot of what is in our pocket, and then the things that are on that phone, the apps that get created, the technology connectivity that comes off of that phone, that device, for all of us, as we live our lives every day. I went on too long, I'm sorry.
Thank you, Ash, and thank you, Bob. Ashley, you have talked to many startups, and from a VC point of view, how's the capital market interest evolved over the past few years over AI and IoT markets? And some say that AIoT hype has already passed. Is that true, or it just evolved to other things?
Both great questions, and if I miss anything, please feel this first or second. Please
Sure.
feel free to rein me back in. What's interesting and is kind of on theme with what we've been talking about this whole time is kind of how you define AIoT and AIoT related. If we look at certain things that maybe might be considered a pure play, for example, Tuya, which went public in March earlier this year. I think they were trading at a high of around 28, and now we're down to 850. So they've been punished a bit. Then you've got related companies like Xiaomi, who's also had a bit of trouble this year in the stock market, but I think recently stated they were committing $1.5 billion to investing in AIoT. But on the other side of things, if you look at other people in the value chain, they can be positioned quite differently, even according to geography. So obviously, we talked about some of the big giants that are winning. But then you also have, the chip makers. Even with the shortage, the chip makers' stocks are kind of out of control. Then you've got some other players like Bosch is doing really well. They made a statement at CES earlier this year that basically only companies that can unlock AIoT are going to succeed going forward. So I think to give an accurate assessment of kind of the quote capital markets perception of AIoT companies really kind of depends where that company is, like I said, located on the value chain, because there's definitely certain players, as I mentioned, chips being one of them, that are absolutely killing it, whereas some of the pure play players and folks outside of the U.S. Maybe aren't experiencing some of the same tailwinds, at least as of the moment. And there could be a variety of factors driving that. It could be geopolitical. It could be also retail investors, for example, all the folks on Robinhood who love the AMD and the NVIDIA and all of that. So it's interesting, and like I said, I think those platform players, chip players, et cetera, they're going to continue to take off. And kind of as Bob put it, people will place their bet on kind of who's going to own categories within that value chain. And I think those companies that are kind of associated with owning those categories are going to continue to outperform the market. I think your second question was kind of where we are in the hype cycle, or if the AIoT hype has passed. In some ways, that might be a bit of a good thing. If you follow the infamous Gartner hype cycle, it talks about there's basically an innovation. Then you get this peak excitement. Then you go through this quote trough of disillusionment, a slope of enlightenment, and then you start to get into the practical side of things, and it plateaus. There can be an argument for kind of where we are on that. If you're a pessimist, you might say we're more in that trough of disillusionment, it's particularly as you see how some of the pure play players have been treated. If you're an optimist and you think about all the applications that we were talking about earlier, then, which I guess I kind of see of us more in that slope of enlightenment, where we're starting to see second, third generation of products. We're starting to see wider adoption, UX that's making it easier to be adopted. And then when we think about all the verticals that this industry will touch, like I said, the quote hype may not be there, but that might be a good thing, because now we might be getting pretty practical and really start to accelerate obviously the fantastic use cases, but also the practical day-to-day use cases.
Thank you so much, Ashley.
Andy,
Yes.
what's also interesting
Yes.
is it's not always version 1.0 that succeeds. It's
Mhm.
usually version 2.0 or 3.0 that succeeds. Most people, maybe Kerr and I are of the age to remember, but the company that really kicked off everything that's been going on over the past decade really was founded and went bust a decade before, which was called Cosmo.com. Cosmo.com was delivering Ben & Jerry's ice cream for $2.95 in 30 minutes in the small areas in New York and San Francisco. They went bust, but it was all about logistics, about scale, about there are a lot of things that come out of the Cosmo.com experiment, and if you count them as version 1.0, that are that are JD, that are Alibaba, that are Amazon, that are now in version 3, 4, 5.0 20 years later. And as someone who lost money and as an investor in Cosmo.com, I find that them, it's heartwarming to me, though I'd certainly take the money back, but that you really understand that, being in there early doesn't guarantee success.
Yes, thank you so much, Bob and Ashley, for the market opportunities. Kurt, you are an engineer and entrepreneur, and you have long time experience in leading tech and semiconductor companies. But this year, the AIoT market also face a lot of, and tech industry also face a lot of challenges. For many companies, quite challenging that they need to deal with chip shortage and supply chain bottlenecks. How do you view those challenges, and how do you advise AIoT or edge AI players?
Well, actually, I think in the AIoT market, if you really look at the semiconductor product, I think really the key is still, going back to the, image processing, right, as ISP and also AI. I actually think some of the companies actually are doing pretty well, right? This is really a big upturn for the semiconductor industry. So we talk about chip company, for example, Umbrella. I just look at their stock. It's really at their high, and they're at 5.6 billion, right? They are actually doing quite well. So I think the market is definitely, growing. I think Bob has really addressed that. This is $1 trillion market. So I believe there are actually, many opportunities there for everybody to play. So I think definitely there is challenge, but there are a lot of opportunity. And in terms of the supply issue, this is probably the most debated topic if you're running a product, company. And this year, in a sense, it's actually not bad because this year, the competition is no longer there. And for many of my friends' company, basically they just say that, okay, all I have to do is to get the allocation from TSMC, otherwise I'm all set. So it actually makes the job easier. So that's why everybody is calling TSMC. I actually think that TSMC is working extremely hard. To improve the supply situation. And but of course, I think on the testing front, on the packaging front, there are still a lot of challenge. So the next guess really is, when this supply situation difficulty will be over. My view is that I think by the end of next year, I think this will be pretty much over. I'm actually running a company called Crossbar, and I was really surprised that actually they already increased my allocation for next year. That shows that they are actually improving their supply situation. And there are also a lot of new fabs coming up, right? TSMC just on the 28 nanometer front, they are building 2 new fab, one in Nanjing and one in Taiwan. So they are basically going to double, their capability from 2 million wafers per year to 4 million wafers per year. So I think, the Westfield is coming, and then probably also interesting to, hear an interview of Mark Liu, the chairman of TSMC. He actually also think that people, double book, and people are really stocking, and try to, just play safe. And once the supply is up, and actually there will be more capacity will be released. So supply is a good, it's in a sense, it's a good problem, right? That means we actually really see the demand there. But I'm just jokingly also say that now TSMC increased 20% of their price for most of the so-called legacy node. That give everybody a good excuse to increase their price by 20%. They pass that down to their customer. So technically speaking, I think for semiconductor, I think most of them, their revenue will increase for sure, because they're forced to increase their revenue because all this price increase by TSMC. So in my opinion, it's a good situation. So yeah, just my observation.
And Kerr, how do companies navigate their future strategies given the fragmented nature of AIoT applications? And do they need to come up with any unified AIoT like protocols? And also, what are some other challenges that you foresee, because you have already run a lot of companies and foresee and give them advices?
Yeah, I think that, I mean, the AIoT is a really broad market, right? It's not a really single, I mean, there's no industry called AIoT by itself, right? I mean, AIoT consists of,
exactly.
I think Ashley mentioned and Bob mentioned, it consists of, I mean, mobile phone, because I mean, it actually does all the AI stuff now when you take a picture and whatever, right, on the phone. And then you have all this, I mean, smart speaker. I mean, those are AIoT, right? I mean, everybody has a, I mean, either Google or a Amazon smart speaker, and this is actually all AIoT. And then if you go bigger, I actually think that all the, I mean, the smart car, I mean, people are talking about, I mean, autonomous driving. You actually have to do a lot of the so-called AI, I mean, on the car other than on the cloud in the future. So this is actually a big AIoT. So I think the market by in nature, they are really fragmented, because if you look at, I mean, all these semiconductor, they are provided by all different companies, and everybody try to keep their competitive advantage. So they, I mean, they want to have something unique. So I think for, I mean, but the general principle is really the same, right? I mean, if you really look at all this AI, I think they, I mean, the principle is really, I mean, all of them are running neural network. They're all running CNN, and I mean, they, I mean, the architecture, we probably want more web evolution, but honestly speaking, I think the AI right now is basically a CNN machine or maybe RNN machine. So it's actually the architecture, in my opinion, is really similar. And so I think to answer your question, I mean, as long as we, I mean, keep the, I mean, current progress, because I mean, with the current architecture, I mean, really, we are talking, I mean, every day we are talking about how to cram more memory into the architecture, and also how to increase the speed of the processor. So as long as we really push, I mean, forward, of course, I think smarter architecture, people are coming up with many of these really smart algorithm. For example, I mean, people are doing like 1-bit quantization, and then I actually think that Kneron, I mean, they did a lot of work on the area to really simplify the application. So I think a lot of innovation around, but I think the direction is pretty much the same for all the company. So in my opinion, just to really, probably to answer the question better, is to say that, I mean, how we actually make ourselves successful, I mean, in this really highly competitive market. I actually think that for a company to be successful, integration is going to be really the key. And if you look at the cell phone industry where I came from, I mean, just eventually there are going to be more and more integration into the cell phone chip. I mean, right now the cell phone chip, I mean, by itself, I mean, it's AI, it's a sensor, it has all kind of communication capability. It has all the A to D, so many of them. You have all the management for battery, management for display. So things would get more and more integrated. So I think for AI company, for AIoT company, success really depend on how good actually they can, I mean, provide an integrated product, I mean, in the area that they know the best. And this is going to be really fundamental. And also, I mean, for people, I mean, who are really at the, I mean, the front of the, I mean, some of this area for, I mean, umbrella, for example, I think they also, I mean, are getting into more vertical area, try to just grab, I mean, knowledge from other and just integrate it into their capability. So I think integration probably is really the key to make a good product in the area that you are particularly in. So I don't know whether I answered the question. So
yes, thank you, Kerr.
That's my effort.
Yes, that's great insights. And Ashley, do you want to share a little bit of thoughts on how do AIoT related startups deal with privacy protection issues?
Yeah, this is a great question, because those issues are only going to compound over time, because one of the nature of AIoT is just that data grows literally exponentially, seemingly every day, and so privacy becomes a concern there. And so I think that it's going to have to be the effort of a few different groups coming together. Obviously, individuals, thinking more about privacy, being more intentional about the products and services they use, and what terms and conditions attached to that. It's obviously going to take, private companies stepping up to the plate there and prioritizing that. It's going to take, government and public initiative as well. Understanding what these platforms are, understanding what the capabilities are, and prioritizing, the protection of data privacy as part of that. And you'll probably see certain regions that are already on top of that, like Europe, for example, with their GDPR, stepping up to the plate to kind of be a leader there. And then the other thing that's all part of privacy as well, and obviously one of the big issues with AIoT and technology in general right now is cybersecurity, and so companies will definitely have to make huge investments in that space, because these attacks and can have a huge ripple effect on privacy as well. Even if you fix things from a policy standpoint, you also have to fix things from a practical standpoint as well.
Thank you very much, Ashley. And Bob, do you have some more closing remarks for AIoT and Edge AI players? And do you expect more AIoT listings going forward?
We definitely do. It's certainly been one that has driven the capital markets. We're in a robust cycle of capital markets activity now, and as I think all three of us have talked about, depending upon how you want to define it, narrowly or broadly, companies are falling into the AIoT platform or specific businesses. We expect to see a lot more coming to NASDAQ in the future. We know that there are fantastic entrepreneurs around the globe who are building terrific products, and we're looking forward to helping them raise the capital to build a new plant or to roll out a new product. So we'll be here to support them the best way we possibly can.
Thank you so much, Ashley, Bob, and Kerr, for all your great insights. That concludes our panel for today, and we will see you all again very soon. Thank you. Bye-bye.
With the conclusion of a discussion of AIoT from a capital markets perspective, we have surveyed everything from the broadest to some of the most influential aspects of AI deployment. On this note, I draw an end to the events of today at the launch of Kneron's next generation KL530. And finally, on behalf of Kneron, I'd like to shout out to investors, partners, customers, and just as importantly, all members on our team at Kneron. We would not be here today without you. Thank you, and we'll see you again.